Hello student. So let us start our discussion. In previous tutorial we have discussed what is direct mapping. Okay, and before that we have discussed associative mapping. Now in direct mapping we have seen that in on same memory location, okay, we cannot have a multiple value with different tag. Okay, means on one index we cannot store multiple value which is having you can say different tags. Okay, so how this set associative memory will be working? Okay, set associative cache organization will work. So let us start our discussion how this data will be stored. Data will be stored into the cache organization. So similarly we will use the index which we have used in previous or direct mapping technique. Okay, so let's say this is index 000 and this is index 777. Okay, now here what will happen that let's say CPU wants to execute this instruction which is on first memory location. Okay, so what is the value of tag? Value of tag is 00. So tag will be stored here 00, and what is data? 1220. So data will be 1220. Then let's say CPU is again executing an instruction, this one 01000. Okay, now what is the index? 000, and what is tag? 01. Okay, so 01 is tag, so it will go to the index 000 and then it will check whether memory location is available or not. Okay, so memory location is available, then along with the tag the data will be stored into the memory. Okay, so here what is the value? 3450. 3450. Okay, clear with this? Let's take another example. Let's say 0111. Okay, this is index 111. So CPU is executing this instruction first time. 11111. So 01 is tag. So first this tag will be stored 01, and then data. What is data? 5849. So 5849. Okay, here we are dealing with the octal numbers, so there won't be 8 and 9. So instead of that we will write, let's say 5431. So here also we will write 5431. Why we have written? Because we are working with octal number system, so everywhere we will write octal numbers only. Then CPU is executing this instruction 03111. Okay, so what is the index? 111, and what is it? Tag 03. So it will go to index 111 and then it will find that whether the memory location is empty or not. So here memory location is empty, so first tag will be stored, and then data. What is data? 8734. So here also again let's make it 7. So 7734. Okay, now if we discuss about last index, let's say 777. Okay, 2340. So first the tag will be stored, that is 00. So tag will be stored 00. Then what is the value? 2340. Again CPU is executing let's say this instruction. So this will be tag, this will be index. So CPU will go to location index 777, then it will check whether memory is available or not. So here it is empty. So first CPU will store the tag and then value. Okay, clear with this? So this is how it will work. Let's say CPU is trying to execute one instruction, 04111, and value is all 1. So in that case what will happen? This will be divided into two part, index and tag. So it will go to this position, index 111, and then it will find whether this tag 04 exist or not. Now here there is no 04 tag and memory is also full. So what will happen? So at that time CPU will go with the replacement algorithm. So most of time in set associative mapping, two type of algorithms are used, FIFO and LRU. Okay, so if we go with the FIFO, then which entry is entered first? This one, 5431. Okay, so then it will be replaced by this value. Okay, and if we are going with the LRU, then we have to consider the multiple execution cycle. Let's say this instruction is used very less frequently. Okay, so in that case this will be replaced. Okay, not because this is last, but let's say if this instruction means if this memory location is used very less frequently, then this will be replaced. Okay, so in LRU list recently used, so let's say if you are going with the FIFO, okay, then this location will be overwritten. So here instead of 01 this will become 04, and instead of 5431 this will be all one. Clear with this? Okay, so this is how set associative mapping will work, and these are the various page replace content or word replacement algorithm in set associative mapping or in any cache mechanism. Okay, so let us discuss that what is the write through and what is write back. Means here till now what we have discussed, CPU will every time bring data into the cache memory, and then every time it will use the data into the cache. But how CPU is updating the RAM? Okay, means whatever data is CPU using, okay, whatever data is CPU using from this cache memory, okay, then how that data is being reflected into the RAM. So let us start our discussion in that. So we are having two options or two policies are there for updating the cache, or you can say RAM, write through and write back. Okay, so let us start our discussion on what is write through policy and what is write back policy. First of all, let us discuss what is write through. Okay, so let's take an example that how write through policy will work. We will take the example of this index let's say 777 and tag is 00, so means memory location 00777. So this value we are considering for write through. Now let's say CPU is using this value, and CPU has updated value, means it has performed some computation, and because of that computation this 2340 is converted into, let's say, 3451. Okay, this is converted into 3451. Now how write through will work? So whenever CPU will update the cache memory, at the same time if that change is reflected into the RAM, then it is known as write through. Okay, so here update will be done in cache and RAM. Okay, so let's say if we are sharing this variable with some other process, okay, so at that time that other process will get the updated value, okay, in write through. But what will be the downside? It will increase the input output operation. It will increase the input output operation. Why? Because CPU has to, after updating cache, CPU has to update that value into RAM also, so other process can use it. Now what is write back? Okay, now whenever CPU is performing this operation in write through, okay, it may use DMA to perform this data updation. Now what is let's say write back? So how it will work? Now let's take an example. We are having instruction which is on location 0 0 0 0 0. Okay, and the value is 1220. So now CPU is using this value. Okay, and after operation this value is becoming, let's say 1230. Okay, again CPU is using this value. Okay, then this 1230 is becoming 1340. Now you see in write back CPU is not going to update this value, means it is not going to reflect this change into the RAM. Okay, means it will maintain only local copy. Now let us assume that CPU is executing some instruction on memory location 5000, let's say 05000. CPU wants to execute this instruction. Okay, so what CPU will do, it will go to index 000. Okay, and then it will try to find empty location. First of all it will match the tag, it is not matching, then it will try to find empty location, no empty location is available. Now that this result into the cache miss. So CPU will try to bring this value into the cache memory. Okay, so here what is the previous value? 0 0 0 0 0, and what is the value? 1340. Okay, now this 1340 in RAM is 1220. Okay, so wherever other processes are using this memory location data, it will be, or they will receive only 1220. Now let's get back to the topic again here. So CPU wants to store this data into the cache memory. So what CPU will do? It will override the tag 05, and at this time this 1340 will be reflected into RAM. Okay, so at this time 1340. Okay, so before the execution of this instruction, means for let's say 2 or 3 times or up to this time, okay, all the other processes which are using this memory address 0 0 000, they will get only 1220, while the value in the CPU is 1340. Okay, so here how write back will work. Update will take place when word is removed from cache. Yes, here what will be the advantage? Advantage will be it will reduce IO operation. Okay, why? Because CPU do not have to update the value into the primary memory. It will work with the local memory only. Okay, now what will be the downside of this? Downside will be data inconsistency. Okay, downside will be the data inconsistency. Why? Because here you can see here updated value is 1340, but in RAM still whenever other process will try to read, they will get only 1220. Okay, so that will be the problem, data inconsistency in write back. What is the downside in write through? It will increase the lots of IO operation. Why? Because after updating each value into the cache memory, it should be reflected into the RAM. Now how cache will be initialized? Okay, so let's try to discuss it. So whenever we will power up the CPU, at that time what will happen, there will be some random value into the cache memory. Okay, so for that we will use one valid bit. Okay, so if valid bit is 0, that means data is not valid inside the cache memory. Okay, and if valid bit is 1, then whatever data is there inside the particular word, it is 1. So initially what will happen, whenever CPU will start, all the valid bits of cache words will be set to 0. Okay, so initially what will happen, initially all the cache reference will result into the cache miss. Okay, and once the appropriate content will be stored into the means once the proper memory word will be stored into the cache memory, at that time for that particular word this 0 will be converted into 1. So CPU can have idea that this is the valid data. Okay, so this is how cache initialization will work. So initially all the valid bit will be set to 0, and after that means after filling all the content of cache word, okay, it will be marked to 1. So while CPU is trying to refer the cache, if it will check whether the valid bit is 0 or 1. Okay, if it is 0, that means CPU is not going to consider that data. It will simply bring the data and then it will put data, and for that particular word valid bit will be set to 1. Okay, so in this tutorial we will keep up to this. We will end our discussion here. Thank you.